Welcome to a fascinating exploration of chemical bonding, where we demystify the fundamental forces that hold atoms and molecules together. In this video, we will delve into the world of chemical bonds, unraveling the mysteries of covalent, ionic, and metallic bonds. Join us on this enlightening journey as we discover how these bonds form and the profound impact they have on the properties of matter. The basics of chemical bonding. Before we delve into the intricacies of various chemical bonds, it's essential to lay the foundation. Atoms, those fundamental building blocks of matter, are bound together by the invisible yet powerful forces known as chemical bonds. These bonds come into existence when atoms engage in interactions, driven by their innate quest for stability through the precise arrangement of their electrons. The comprehension of chemical bonding isn't merely an academic pursuit. It stands as a fundamental pillar that dictates the very structure, properties, and behaviors of all substances across the vast expanse of the universe. In essence, it's the key that unlocks the mysteries of matter and underpins the functioning of the world as we know it. Covalent bonds. Sharing is caring. Covalent bonds are akin to a cosmic handshake among atoms, representing a partnership where electrons are shared in pursuit of a stable electron configuration. These bonds primarily take shape between nonmetal atoms, fostering a realm of molecular diversity. From the humble diatomic molecules such as oxygen, O2, where two oxygen atoms join in a covalent embrace, to intricate organic compounds like glucose, C6 hydrogen oxide 6, covalent bonds are the architects of molecular complexity. The act of electron sharing between atoms is akin to a dance, influencing the very geometry and properties of molecules. The way electrons are divvied up among the participating atoms shapes molecular structures, determining whether a molecule is linear or bent, polar or nonpolar, and ultimately defining its unique chemical behavior. Covalent bonds are the cosmic handshakes that allow the world of molecules to take on its remarkable diversity of forms and functions. Ionic bonds. Electrons in transit. Ionic bonds are a captivating facet of chemistry, characterized by the transfer of electrons from one atom to another. This exchange results in the creation of charged ions, atoms that either gain or lose electrons to become positively charged cations or negatively charged anions. The magic of ionic bonding lies in the electrifying attraction between these oppositely charged ions. In compounds like sodium chloride, and calcium carbonate, CaCO3, the positively charged sodium ions, Na+, are irresistibly drawn to the negatively charged chloride ions, Cl, and calcium ions, Ca2+, to carbonate ions, CO32, forming a crystal lattice structure. This unique arrangement gives rise to some remarkable properties of ionic compounds. They typically exhibit high melting and boiling points due to the strong electrostatic forces that must be overcome to break the crystal lattice. Additionally, when ionic compounds are dissolved in water or melted, their ions become free to move, enabling them to conduct electricity, a property essential in various technological applications and chemical reactions. Metallic bonds. A sea of electrons. Metallic bonds, often described as the glue that holds metals together, are a remarkable phenomenon in the world of chemistry. In this type of bonding, electrons, typically found in the outer energy levels of metal atoms, become delocalized, meaning they are not tied to any specific atom and can move freely throughout the metal lattice. This electron delocalization creates what is often referred to as a sea of electrons. It's this unique characteristic that gives rise to the exceptional properties of metals. The delocalized electrons act as a cohesive force, allowing metals to be malleable, meaning they can be shaped without breaking, and ductile, which means they can be drawn into wires. Moreover, the free movement of electrons is responsible for metals' remarkable electrical conductivity and lustrous appearance. This type of bonding is pivotal in shaping the world of engineering and industry, as it underlies the production of a vast array of materials and products, from electrical wiring to structural components in construction, making it indispensable to modern civilization. Bonding and properties. As we wrap up our exploration, it becomes clear that the different types of chemical bonds have a profound influence on the properties of substances. Covalent bonds, formed through the sharing of electrons, give rise to a diverse range of molecules. For instance, hydrogen gas, H2, exists as a diatomic molecule with low boiling and melting points, while carbon atoms in diamond, C, form a covalent network structure, resulting in its remarkable hardness and transparency. In contrast, ionic bonds, characterized by the transfer of electrons between atoms, led to the creation of compounds with unique traits. These compounds are often soluble in water due to the strong attraction between ions and can conduct electricity when dissolved or molten, as ions become mobile. Lastly, metallic bonds, where electrons flow freely in a sea of delocalized electrons, bestow metals with exceptional thermal and electrical conductivity. This understanding of the relationship between bonding and properties is fundamental in fields ranging from chemistry to material science, underpinning the design and application of countless substances and materials in our daily lives. We hope this journey through the world of chemical bonding has shed light on the intricate forces that shape the matter around us. From covalent bonds based on shared electrons to ionic bonds driven by electron transfer, and the unique electron sea of metallic bonds, each type of bond plays a crucial role in the diversity of substances in our universe. If you found this video informative and insightful, please give it a thumbs up and share it with others who may be interested in unraveling the mysteries of chemical bonding. Don't forget to subscribe to our channel for more educational content, and hit the notification bell so you won't miss any future explorations of the fascinating world of science. Thank you for joining us on this journey of discovery. May your newfound knowledge of chemical bonding enrich your understanding of the world around you.